I'm Jake Bruden, and welcome to the Unbuild It podcast. Before we get started today, I want to give a special thank you to Huber Engineered Woods, our sponsor for today's episode. And rather than talk about their products or their customer service like we normally do, I want to make you aware of something that's happening at the International Builder Show. The first day of the International Builder Show this year, Tuesday, February 25th at 10:30 a.m., join myself, Steve Basic, and Huber's own Nick Sable at booth C3320. That's C3320, 10:30 a.m. We're going to be talking about rain screens for resilience. Everything rain screen. We're going to be covering everything that has to do with rain screens in one conversation. Myself, Steve Basic, and Huber's Nick Sable. You do not want to miss this conversation. It's going to be super informative, crowd participation, everything you've ever wanted from a rain screen conversation. Be there or be square. Huber, thanks for sponsoring, and we hope to see you guys at IBS.
Hello, Unbuild It podcast. How you doing? Howdy. We're down in Texas, but we brought Minnesota with us.
Thanks for having me.
We have the one and only, which I'm trying to understand whether that's a blessing or curse, Eric Aune. He is Mechanical Hub on Instagram, which he has like, 5 million followers. So you're probably following him anyway.
And don't know his name.
You
just know it as Mechanical Hub.
It's Eric. And plumbing, heating contractor extraordinaire, might I add to that. And today's topic of discussion, though, we are just going to talk about water heating because he is all about it. He's actually cut a water heater in half to see what's inside.
I wondered if we were going to get into that.
Of course we are.
Right off the bat, you had to bring that up. That's your favorite video.
That's my favorite video. If you haven't seen Eric cutting a water heater in
Eric's or somebody else's?
No, it was Eric's.
I've done more than one though, so it's just to help you out, to entertain you when you're.
I find it
a slow day.
Very intriguing. Very intriguing. I don't have slow days, but that does speed it up.
Well, what do you guys want to talk about? Heating water.
Water heating. Let's talk about options.
Options.
Yeah.
Well, obviously, the most popular option these days seems to be electric, right? Everything's going electric. You guys talk about it a lot. You're building with a lot of electricity. So we're doing heat pumps. It's pretty popular these days, although less popular maybe as far north as I am. I think the general community is still kind of trying to wrap their mind around the idea of putting a heat pump water heater in their house, where in the wintertime we're paying a lot of money to heat those houses. Maybe the less, efficient.
That's because you guys don't build good houses up there.
That's what I was getting at. Maybe the less efficient, less fuel efficient, lower performing houses, that kind of thing. They don't seem to be quite the favor yet, but they're getting there for sure.
So what's the predominant fuel type there?
Natural gas where I'm at for sure. We're working the Twin Cities area and north within about an hour range or so of Minneapolis. So natural gas is number one. And the other side of that, really the competition to that would be electric.
Okay.
Get in the rural areas, you see plenty of LP.
What about, I've recently I've wanted to install it. I never have, electric, instantaneous.
Yeah, much. I've got some experience servicing them and seeing them, having been installed, maybe years ago and housing developments.
I want to back up. When you say instantaneous, you mean a tankless unit. And when we say tankless, most of the time, it's almost always gas.
Right.
And when you say electric, you mean literal, just tankless. And I've only ever really seen them as a point of use tankless, not a whole home tankless.
No, so they make whole home systems.
Yeah, they've been around for a while. There's major players in that industry that make capable tankless, electric tankless.
I just want to make sure we're on the same page.
Yeah, Stiebel Eltron's a big German company. They've got product out in the marketplace all over North America that does whole home electric tankless. They're not super popular simply because of the amount of power you have to bring in to supply.
Right.
Are those 3-phase units? Like that sounds
no,
like
well, I mean residential.
huge endeavor.
No.
Residential, but you're looking at maybe in some cases a couple 60 amp breakers, to heat hot water. It's doable. It's just not super popular. About 25 years ago, in just some outskirt areas and rural areas of the Twin Cities metro, we saw a few neighborhoods popping up that the electric utility was pushing electric tankless. And for the most part, I think the residents are happy with what they're getting at the faucet.
They're pretty inexpensive first time costs. Like you can go, I've gone and looked at like Home Depot. You can give like $450 for a whole house water, instantaneous electric hot water heater.
They are, well, and they are less. They're roughly, these days, are about 50% of the cost of condensing gas.
Right.
And that's that first cost, though.
Right.
Installation is going to be lower unless they've got to do a whole ton of electric work to accommodate for it. But if you're in a mechanical space,
2 enormous wires to it.
Right. Well, if you're in a mechanical space where the panel's at or something like that, that might be more affordable on that upfront cost. Operational, though, they're not.
No. I realize that, but like I just saw one recently, and it's for, I won't say a second home, but more of like a cabin lodge type environment where someone might go 5 days out of the month.
Right.
And you go there and you don't have to worry about anything. It's like, yeah, you pay that penalty, but there's no standby loss. There's none of that.
No turning it on away mode or vacation.
Yeah. And or waiting. It's like you can go there, click the switch, jump in the shower, and you have hot water.
Yeah. The great thing about something like electric tankless, just when you get on the control side of things, the wiring and, maybe you've got home automation, things like that, you can very easily use a very simple relay to interrupt power to it. So even just when you set like a thermostat to away mode, you can actually just turn that off, because some of these things are maintaining temperature while they're sitting there, just a very small volume of water. We call them tankless, but
there's a gallon in it.
There might be, it might be a couple liters or a gallon of water in it just to eliminate like that cold water sandwich. But yeah, it's doable.
What does cold water sandwich mean? I've never heard that term before, Eric.
That's a plumbing term.
Yeah.
I got that.
Yeah.
Okay.
It's
trying to help out.
It's pretty simple, really. You run water at a sink, walk away for 30 minutes, go back to that sink, run hot water again. And what's happened is maybe the water in the lines have cooled down. And with the tankless, it's the same phenomenon with the tank, really. You've got some cool water in between bursts of hot. So we call that a cold water sandwich. And it's really not awesome when you have like the old tankless technology. You didn't have that small storage. You might have a certain amount of cold water that would go through the unit before it fires up and it goes to the faucet. That's not great when you're naked standing in the shower and you've been there for a minute and now all of a sudden, boom, a little shock of cold water. That's what that storage is doing inside these things. It's just never allowing any cool water to pass through the line to the faucet.
Cold water sandwich is a good way to describe that. I know the phenomenon. I just never heard that term before.
Cold water that either ran through the unit or cooled down in the pipe and then, delivered hot on the backside of it.
Interesting.
People do not like that when they're standing in the shower.
Yeah. Okay, so we've covered two of the electric side of things. We kind of glazed over what I think is still probably the most purchased in the United States, which is electric resistance, though, right?
Yeah.
Am I wrong on my statistics there?
No, number one in North America, Canada, United States, number one would be electric resistance tank water heaters. Really, no matter what state you're in. Maybe in the Northeast it's less prevalent, but they're still using where they're still using a lot of fuel oil. Electric tank water heaters are very common because they're inexpensive to install. They're inexpensive to purchase. Lifespan on them is pretty good. There's really no moving parts on them.
And it partners with fuel oil in the Northeast because the fuel oil is not going to be the thing that's heating your water in that instance.
It's less efficient maybe to use a fuel oil boiler to heat domestic hot water. They usually do the old cast iron boilers. We're doing them with what they call a tankless coil. That's a copper coil that's installed in the cast iron heat exchanger. So it's more of that's where I think the term instantaneous comes from. is that region where as soon as water runs through that coil, because that coil is so hot, the boiler is being kept warm all the time, that it's able to produce a fair amount of domestic hot water just by flowing through it.
I also think people have finally started to realize in the boiler community that maybe we don't want to run that darn thing all summer just to keep
hot water
40
going.
gallons of water going.
Especially while that's not like a new phenomena, but as you see the fuel prices spike, that's the first thing that they're looking at. I'm a fiddler. That's the first thing that they're looking at to get rid of is to like eliminate this coil on the boiler. The boiler can remain. They can just disconnect it, and they're usually installing like a 40 or 50 gallon electric tank.
Yeah. That's
pretty normal.
Okay, so we did start with heat pump though.
Yeah.
And there is the detriment of running that heat pump indoors in specifically your climate.
Yeah, it's interesting. There's a lot of challenges there. Ultimately, the first challenge is the same no matter where you're at, unless you're installing these things outside and you're in a warm climate, is just having the volume space.
Because you need like 700 or 800 square feet.
Cubic feet. Yeah.
To communicate.
To communicate the heat requirement.
Yeah, usually your 7x10 room is like, that's the minimum, right? And I think after a number of years of, I first installed a tanklet or hybrid heat pump water heater about 10 years ago. And the technology wasn't the same as we have today. It was really one of the first models onto the market. And we ducted it outside so that we could pull warm air in the summertime into the space for the unit to make hot water. But then we had to duct it outside on the exhaust in the wintertime. Otherwise, we're pulling warm air from the basement mechanical room, but we're dumping all this cold air. And it was making, there's one basement bedroom in that space, closed off and separate from the mechanical room, but it was just, freezing the basement out all winter long. And so that's our challenge, the volume. And then cold climate like we're at, where we're in heating mode for 6 to 7 months of the year, ducting in and out and based off of season is really a big thing too. So I've got a project coming up where I'm going to be installing one of the newer models to the market. It's in a space that's 7x10. It's not large enough in my opinion. It's way up on the North Shore, Lake Superior, extreme northern Minnesota. And so it's a long heating season. The boiler's in that space. That room is always hot, which will be fine to pull heat from in the wintertime. But in the wintertime, we don't want to be dumping that cold air into that space either, because then you're going to have poor performance on the heaters, on the heat pump side. And it's going to have to, we'd have to go to something like a louvered door or something like that to open up the space a little bit to communicate.
Now we've done that, but then we've had the noise issue. You
have noise. And actually, if you look at the parameters by the manufacturer for these heaters, you have to be, it's kind of a lost cause, because these things the manufacturers are saying these heat pumps need to be within like 12 to 18 inches of those louvered openings and things like that for it to communicate properly. And otherwise, you're still just in that same kind of scenario where your volume of space is too small. That shouldn't stop people from thinking about these. Yeah. There's ways around it. Like I've just talked about, it seems a little complicated. Maybe with a drawing, it would be easier to understand. But yeah, you're either ducting because you're pulling heat from the outside, or you're ducting to the outside because you don't want to dump the cold in the space.
So Steve and I are finishing a house right now in central Missouri, and the clients are putting one in the garage, and we're putting ductwork on it. And the HVAC guys came and connected it, and they didn't insulate the ductwork. And the idea is they're going to be able to either plumb it into the garage or turn it so that it plumbs outside. They didn't insulate the ductwork to start out with. It's a very rainy spring and a very warm spring. And like the first day they hooked up the ductwork, I was very proud that one of my carpenters sent me a picture of it. And he was like, HVAC guys plumbed this today and turned on the water heater. Is it going to be like this every time it's warm and rainy?
Is it just raining?
And it's just dripping off the ductwork. And he goes, I guess it's okay because it's in the garage. And then there's just this question mark.
Yeah.
And I was like, I was very proud of my carpenter to go like, it's cold enough that it's condensing and there's enough available moisture in the air. And I was like, yeah, this is going to be, at least it's in the garage kind of conversation. Like, I don't know if we could get enough duct insulation around that thing in that environment that, like, boy, that would be a tough one.
Well, and it's got to be done well, right? There can't be any gaps. It has to be sealed up. You're looking at minimum R10.
Yeah.
And which is, normal for duct wrap. But if it's not done well, it's going to be a huge problem with humidity for sure.
Have you done much with air to water systems?
I'm just starting. I haven't done very much at all except for studying them. Some training classes. I haven't installed any yet. I'm working on one coming up in my shop for hydronic system. And then to I guess either take the place of my gas boiler completely or just add to so I can toggle between the two. I'd like to work on a project, maybe one of yours coming up for domestic hot water. Those have been less popular so far simply because on the domestic side in our climate, it's maybe not the best option, right? Okay. For heating,
not the best. How?
You're going to have some sort of backup heating system installed on them.
When you get as far north as you are, there's not enough available heat outdoors in certain parts of the year. That
for a lengthy amount of time, yeah.
The efficiencies go way down, and that you just can't get the water hot enough to satisfy the needs of some families.
And so if you just have a cold water sandwich.
Well, if
it's just between January and
exactly.
I think we got the title of our episode, by the way, cold water sandwich with
2 or 3 week long cold water sandwich is not going to be acceptable to my customers. At least not any that I have yet to work
for. We're brand name wise, is it Sanko now?
Yeah,
it's
I think they've
Sannon anymore.
Yeah, it's Sanko.
It's an outdoor cassette like your mini split, and inside the only thing that happens is a tank where they mix cold and hot. And so I had recently we had a full week where we didn't get above 0 Fahrenheit, and we noticed no challenge whatsoever.
And that's air to water.
Yeah,
that's air to water. So you're looking at, and it's domestic. So they're able to use system like that. It uses CO2 for refrigerant, which is nice for environmental purposes and for performance. But ultimately, you're able to do that because you're storing a mass amount of water. And it's the cassette unit or the unit outside, the outdoor unit, that's similar to a mini split. It's what's called a monoblock system. So it's really just you're heating this mass of storage, mass outside as well. So that's pulling a lot of energy out of the unit, and it's contributing to the mass of the system. And so mass is really the name of the game. So if we can have a large indoor storage tank and we can make water, slowly, but store it in a large quantity at a higher temperature, then you can have performance. But if you get down to that 0 negative temperatures, there's a lower limit regardless. And just like any type of heat pump. Yeah. So it's challenging in the colder the climate, it's more challenging to use the system. It's not totally doable, but you're going to have a backup system, something that's going to work in tandem and automatically. Nobody would accept any type of, manually switching from one to another unless it were like a plumber in his own house. And even then I wouldn't want it.
Well, I mean, even if I were going to try something like that at my house, like the second it's like, oh, you're gone on vacation for a week in somebody's house setting, now your house doesn't work.
Yeah.
Like that society just doesn't operate that way.
Well, and that's why we see our tanks, and even I'm sure that Sanko system has at least one resistant element in it.
I think it has an option, and I think that ours is self-regulating, and it does, but it is very small because the system runs off of a 15 amp circuit. Like, it is very small.
Well, believe it or not, most heat pumps for these split systems, we're installing them with 30 amp circuits, but a lot of them are closer to that 15 to 20 amp operating requirement.
Yeah, I think mine says 12.3 or something. Like, it's a very small
that's
draw. Basically
startup, right?
Yeah.
Maybe that system has a element like in the outdoor unit. I'm not sure.
Yeah. That's the only place there's power. There is no power at the tank.
So then so they've got electric resistance built into the outdoor unit. Yeah, that's huge.
Which isn't even like heat tape on the line from the unit back to the house. Like, there is nothing to protect that. I put in heat tape to deal with that, which is another, like, do you ask your clients to monitor heat tape yearly to make sure that was my first, I'll do it at my house, but I don't know. I got to have a pretty darn responsible.
I get a little nervous about those systems. You ask, about the cold climate and stuff. I get nervous because it's just 2 water lines run out to this outdoor unit from an indoor tank. And I know insulation works and you can heat tape it, but I also know that it gets 40 below where I live at least once or twice a year.
Yeah.
So like that makes me nervous to think that I've got water pipes that are more or less exposed
to R4 insulation wrapped around them.
Yeah, you could do some things, maybe put them underground would help, stuff like that.
Yeah. Okay, so if we're not talking electric, then where do we go from electric?
Well, back in the, what's really normal, or I guess the most common in our area for the last 20 years or so, with new construction booming in the late 90s, we already stated there's a ton of natural gas where I work. So many power vented water heaters. So a power vented water heater is basically a standard water heater with some added electronics and safeties built on it with an inducer motor on the top, a fan to exhaust through a plastic pipe. Draws in a bunch of room air, can cool down the exhaust flue gases, and so you can use a plastic pipe to exhaust. That's really normal. You get into multifamily and stuff, you start seeing things like atmospheric water heaters, or you start seeing, district heating for larger complexes like townhomes or apartments where you use boilers.
So when I think the plastic pipe thing is a good thing for here's a great teaching 101 moment. If you're looking at a water heater and you see the metal pipe with the space between the water heater and the metal pipe versus the plastic pipe, you can infer something about efficiency very quickly that you are educated that maybe the homeowner's not. Can you walk us through that real quick?
I think I could dispel a myth that you may have in your head on whether or not a water heater is efficient simply because you're using a plastic pipe. Okay. That's where you're going with that. You. I thought so. Thank you. So a lot of people, let's dial back one step. So condensing furnace, right? We see them. They've been around since the 90s. You've got maybe 2 plastic PVC pipes, maybe polypropylene, something like that, going to the outside. One takes in air, one exhausts it.
I have one in my house.
Yeah, 92 plus, they call them, 92, 90%.
I have that Vidaris, the white cabinet one there.
There you go. And so you've got an intake and exhaust, direct vent appliance, typically very high efficient because it's condensing, things like that. Operates in that combustion efficiency range of 90+%. Mm-hmm. Tankless water heaters are that way when we're hooking them. Condensing tankless water heaters, very common. But we talk about a standard tank water heater like we just brought up. Atmospheric vent where you've got the draft hood, the metal pipe probably goes up through the chimney, through the roof. And then there are variations of that, but then you've got the power vent, like I've already explained, with the exhaust going out the sidewall, plastic pipe. We would think that it's efficient because we have this plastic pipe, but ultimately if you look close at it and how it really works is at the draft hood or the exhaust inducer motor, there's all these little holes cut in it and it's drawing in room air and it's mixing that room air right at the outlet of the water heater flue gas at the chimney in the water heater. And that flue gas is very hot, 170, 180, 190 degrees. Depending on the size of the burner and the water heater, but it's mixing it with ambient temperature air and it's able to bring it way down below maybe that upper operating limit of the PVC. The idea is that you look at it, it's PVC, and just like my furnace must be high efficient, but really they're almost the same, maybe 50, 60, 65% efficient. So it's really just a different way of installing the more or less the same type of water heater.
I got to hear my HVAC guy tell a client that in the last 2 weeks. And I was like, I'm fairly certain that's not true. When we were walking out to his truck and he goes, no, that's why they can use PVC. And I brought it up.
You could just look at the ratings. They're Google. The same.
I was like, well, I'm not going to walk back in and make you read what the water heater says.
Yeah.
But let's have a conversation about this.
Now, don't get me wrong. You can get higher efficiency. Yeah, you can get 90+% efficient tank water heaters. There's no doubt.
Yeah,
they're more on the performance range and application range for light commercial. They work really well for restaurants that might be burning gas for domestic hot water. But they're not the most typical thing we're going to put in a house simply because they're not cost competitive with other type water heaters.
Okay, so I want us to spend 5-10 minutes on a selection process for a water heater. we're just going to assume that it's a new construction and the existing conditions are our neck of the woods where each one of us might build normally. So like in Boston or in your neck of the woods or my neck of the woods. And we're going to talk about why we might choose each one of the things that we might normally choose. And there can be your caveats in whatever you might say. Like, so I know your sales pitch for your clients might be different than mine. And I just think that it's a valid conversation that we're all going to have a slightly different take on, well, it's what's right for you and your family. I do assume that probably none of us are going to say, let's put in an electric resistance water heater. Although Steve's going to say that now that I said it. But I would like to have this conversation.
We have looked at them. We never did one. We never did one, but because there's just like if you're doing an ADU or something, and it's like, how do we get something out there? You don't have the space for a big water heater. You know.
Well, we are putting in one right now. The zero concrete house. We're putting in a 30-gallon low boy that just fits in that. Like it has one bathroom in it. And it's what we can get out there and fit in the space without it being in the way. So we are actually putting one in right now.
Did you consider electric tankless for that project?
We didn't, but I wasn't in the decision-making process of that, so I can't make any conversation about whether or not. I just know what they're putting in.
I have before we get into what would you choose, I have a question because I tell clients this, so it'd be nice if you either agree with me or tell me I should have a different conversation with them. But occasionally we have larger houses, say like a 3,500 square foot ranch.
Okay.
And you know, the owner's suite is over here. The kitchen and laundry room are over here. There's another bathroom over here. So it's not inconceivable that between 2 or 3 devices, we might be 110 feet away from each other. So what I tell the homeowners is rather than put in, say, one large 80-gallon heat pump water heater, we downsize and we'll do 2 50s. And we'll put one in the basement underneath, say, the owner's suite. So they get, it's like 8 feet to hot water. And then we'll put another one over somewhere else. And the plumber will then connect the two too, so that if one failed, we can service the whole house off the one that operates by throwing a valve, which I think is possible, right?
Yeah, it's completely, I've seen that before.
But what do you think about like splitting it up and instead of having one larger water heater? And keep in mind, it's, there's a lot of decisions.
Clients with no budget.
Well, it's not clients with no budget, but clients that probably care about comfort before cost, right? Like I have clients that don't want to turn the shower on and wait 3 minutes for hot water.
I don't know anybody that does. Yeah.
Right. So, but they're financially capable of being able to make that decision.
Well, it doesn't have to be a high cost to have hot water now either. So right. I understand what you're saying, but that also doesn't have to be expensive.
But is that a good idea? Like to take instead of one water heater for the house, we split it into 2 and put them in
for performance? Yeah. In my opinion, I don't like it at all. And here's why. It is totally acceptable to do that, and it will perform better than, depending on what you're using. So if you're using heat pump water heaters, it's probably
these are Rheem
it's probably a great way to do that because you have to look at their total demand, right? So that's how we size everything. And so total demand, we can't put in, we can't probably hit the full demand on one even 80-gallon heat pump, right? But if we split it up and maybe we put 2 80s and we put them where they need, or maybe it's a 50 over here and it's an 80 there or something like that, then you're taking care of the needs, right, as a whole. But you are complicating the piping system, right? And also you address the fact that if one were to fail, you can maybe pick up with the other by piping between the two. But that's even more piping that needs to be installed, time, labor, maintenance,
more cigarette butts you have to pick up because the plumber was there an extra day.
Do people still smoke? But then
for us, it's drywallers.
Yeah.
Once the drywaller's there, like out by the front door, you'll see there's like 10 butts on the ground.
Oh boy. I always see the monster cans that aren't full of Monster. where we were going, just the complication of it, right? So there's more plumbing.
Yep.
There's additional, now instead of one power source, whatever that is, gas, electric, whatever, now you've separated, you've got to have two. If you have to duct them, now you're cutting more holes in the house, things like that. With a heat pump, for example, it is more complicated, but it does address the performance. And I know that's where you preface most of it. Your clients are mostly worried about performance. I know that because I deal with customers that have lived in a home that they probably didn't build or that they built 20 years ago and they've never been happy with it since. And now that's my customer. Mm-hmm. I deal with the existing homes all the time. So I look at your solution and I don't say it's not a good solution, but I look at it and I think, how could it have been done differently so it's more simple? Because more simple is always easier to maintain, lower cost to replace, probably more reliable, right?
Okay. So question 2.
Not just recirc.
I think recirc with the right sized.
They used to do a ton of Metlin systems.
I'm not.
I think it's METLUND.
Metlin's just a pump brand.
Yeah.
Oh, okay.
That did a water circulation. We'd put the switch by the master bed. Mm-hmm. So people would wake up, roll over, hit it. And by the time they got in the shower.
So the first time that I had a client talk to me about a recirc system, he said, can we just do a push button for the pump? And I said, why wouldn't we just do a motion sensor in every room that has water? So you don't have to push a damn button. And that was what we did. And they've been really happy with it. We've done it 3 or 4 times where it's just like, then the pump kicks on when you do it. Now, Eric talked me into doing a pump at my house that is working great. I'll let you talk about it because it was your recommendation. It's fantastic.
So you can just automate it. I mean, and it can be autonomous. It doesn't have to be connected to any appliance either, as far as like the technology goes, right? So we can install, you can install a tankless water heater that has a pump built into it. You can install circulating systems that are connected to the water heater, to your heat pump, that are going to operate on timed, like time of day, or there's even AI systems built into these now. The system you put in, I think, is great. It's made by Taco. That's, you're familiar with Taco because you live in heating country, but like they make this small polymer
taco for those of you that are good at
polymer body. So it's, going to last for a million years, never going to leak, that kind of thing. Small ECM motor circulator. So it uses LED, power levels right here. And then there's this little crossover valve you can put in like a far sink. And what you do is you put this at the point of source. So your water heater.
So I didn't have a recirc line in my house. This is an afterthought because we had an issue. My lines were not run properly. I didn't think about it. And my wife complained about she was right. It took forever.
It's a great solution for either direct, return for recirc or no recirc system at all.
So the bypass from the hot supply at the furthest appliance to the cold supply at the furthest appliance.
And you can put up to 3 of those in a system. So you can actually retrofit very easily existing plumbing, or on new construction, if you put in a dedicated return line, you can use this. What's really cool about it is the control for the pump. There's different modes where it can run like 5 times on in an hour, 10 times on in an hour, something like that. And then it also has a learning mode where it'll literally every 7 days learn how you use your hot water. That's where we're using, like, in my opinion, that's where this latest technology is really making a lot of sense, where it helps us save energy. But like you were saying, Steve, your customers really don't care as much about that. They just don't want to wait.
Right.
Look, that's saving energy too, because if we're waiting for hot water to show up, we're watching cold water that we heated one time go down the drain. All of that adds up over time. That's the impetus of how they've invented those types of products. That's why they're affordable and out in the marketplace, and we're using them. I think they're great.
So my next question is, we're building a new house, running the hot water plumbing to, say, the different bathrooms. Do you favor running a home run to each device, or running a home run to the bathroom and then splitting it amongst those devices in the bathroom?
I prefer what we call, like, Uponor has they call it their Uponor method. Viga has another, they're using main lines, but not trunk and branch, where they're putting small manifolds right at the the point of use. So like to deliver for a bathroom, and then maybe continue on with recirculation or to a next bathroom group, that kind of thing. I prefer that method because it's again, it comes back to being very simple. There's less piping in the house, although the numbers don't lie at all. When you use like a home run method, small diameter tubing, you're overall using less water to fill the system, to operate the system. But I'm not talking about like flow rates and things like that, but just literally like the volume of water that's needed. Yep. And that comes into play when you're talking about heating, right? Heating water. But I prefer like that main line with the small manifolds because you get rapid.
And the manifolds in the bathroom or
usually,
bathroom,
so like think of like a hot and a cold, maybe like 3/4 inch lines coming from a mechanical room, and your bathroom is 30 feet away or something. But then you've got additional plumbing even further. So what you can do is just run your properly sized. I'm using 3/4 because it's pretty typical for residential. But you've got a hot and cold coming from the mechanical room, and you'll route the plumbing directly to that bathroom space, and then maybe it's coming below the floor or overhead, but then you've got these small little manifolds that are in line on the main line. Maybe it has like 2 little openings. They're like T's, but there's less connections on them, right? Okay. Or maybe there's 4 openings on it, 1/2 inch off the 3/4.
So
line.
It takes the 3/4, breaks it down into 3 or 4 little
But then
lines.
It keeps going. So your fixtures are pulling more or less like a home run system from those 2 main lines.
I got you.
Very little piping, less fittings, things like that. It's really nice because it equalizes that. It lowers that pressure drop through the system, right? You've got 2 main lines, small, relatively small diameter, 3/4 inch pipes, maybe 1 inch, depending on the size of the space or how far you have to go. But you're pulling off of those main lines on a short section. You can recirc with a system like that because these fittings, these little manifolds have like flow through. Gotcha. So you've got a direct connection on the other side. Maybe you just return back to the heater, or maybe it picks up another bathroom, stuff like that. For anybody listening or watching, you could look up the Uponor method. That's something that Uponor, the manufacturer, PEX manufacturer, is something that they've, in their marketing side of things, called it. I don't think that they invented it. Another company, major PEX manufacturer in North America, German company, Viga, they have the same type of fitting systems that accomplish the same thing. Nibco, Zern, Watts, they've all got similar types of systems. And the idea is that it comes into play for great flow. You've got, you're able to put a lot of, the proper gallons per minute throughout this system, but you can also do the recirc, and you're not doing it's very simple piping.
So if you install that system and now I want to swap the toilet out, can I go to the manifold and shut the line to the toilet off, or do I have to go back and shut the 3/4 inch line down?
Well, you would have a shut off at the toilet. Yep. But if you needed to work on that water pipe or something like that, or replace the valve at the toilet, you would have to shut the house off.
Okay.
Unless
when he says manifold, he just means a T in the system.
Okay.
Basically.
All right. So it's not something like that you're opening and closing. It's perpetually open.
Yeah.
It's just distributing. Sorry.
Yeah. I guess technically we call them manifolds because it's a terminology we're used to. They're called multi-port T's. And so a multi-port T might have a 3/4 in and out, and on the branch maybe have 2 or 3.
So that's why our plumbers charge so much, because they use, they can't just say, oh, it's just this T. No, this is a multi-port T.
Yeah, it sounds like
this
more
is doing a lot more. There's a bunch of T's that we're putting together. This stuff's really expensive here, people. But no, because the reason it drives that question is I have a lot of engineering clients that, like, in their mind, I want the ability to shut each individual plumbing fixture off. So they just go down to the manifold and master toilet, click, and then they can go do whatever they want.
Which in reality, how often do you need to do that? You have to have a shower going at the other end of the house while you work on that.
I get it. I'm with you.
But we've done that before. We did that at the Slab with Slab house.
That's how people think. Some people.
That's great. I work on their houses 20 years later, and nobody's touched those things, and they don't operate. So that's the way it goes.
I don't see a lot. Like, there was a time probably, 15 years ago, like the manifold, like every house.
Yeah.
Bang. It was like an electrical
home run system.
Right. Home run system to it. And
sells a lot of PEX that way, right?
I haven't seen one in a while.
More pipes that way.
I haven't seen one in a while. And it's funny that plumbers are becoming more efficient. That's weird to me.
Yeah.
But okay.
I bet it is for you. No,
it doesn't charge by the fitting.
Yeah.
I'll tell you, honestly, I'm not trying to be, negative. I honestly think that method is a good piping system if done certain ways, and certain ways are avoided. But I honestly think it came about to sell more pipe.
Okay.
We got a whole bunch of 1/2-inch pipe we're not selling.
Right.
How can we sell more?
That there was some level of nefarious means behind the capitalist.
No, we'll just call it commerce.
What about copper versus plastic? Where do you sit on that decision?
Well, I think you could find information that would support.
I'm asking Eric's godlike opinion on copper versus.
He wants to know the mechanical
plastic.
hub take on it.
I want the mechanical hub take, not what. Well, if your studies tell me this, if you're building your own house, would it be all copper? Would it be part copper?
We did PEX in his shop.
PEX?
I do both. I think copper
Fence
is.
sitter.
What's that?
No, I mean,
No.
Talking to Switzerland.
No. Hold on.
Hey.
The majority of it would be PEX. Okay. But I do both. And I say, because I like the near heat source piping, the connection near the well where maybe we've got some control valves and things like that. I like that to be copper. It's just
from
nicer.
A rigidity standpoint.
Okay. It's easier to insulate. It's easier to support. It's easier to plan out and utilize, maybe take up less space to accomplish the same things.
Okay.
Where you can go back to that terminology manifold, where that truly ends up being a manifold, your cold line coming out of the meter, the cold line coming off your well, where you've got your silicox are connected there. Then it goes into your water conditioning. So you've got maybe a series of valves that are controlling lines here and there for service work purposes. But then like that being copper is nice. It really just is. It doesn't mean that other piping products aren't as good, but I think distribution throughout the house. Look, we've more than proved that PEX, polyethylene crosslink tubing, is reliable, performs.
I mean, some of the manufacturers give a 200-year warranty on the pipe.
Yeah. Well, I mean, I wonder if in 25, 30 years, if they're going to honor it. But I've been installing PEX for new construction and service since 1998, 1999. And I can say with confidence that failures happen, but it doesn't seem to be a manufacturing issue. It's usually installation or extreme water quality, where other piping probably wasn't going to be any better anyway. You've got areas of the country where copper piping isn't a good option at all.
Right.
In the Northeast, you've got New Hampshire has high pH levels, areas in that. I'm throwing out New Hampshire. I don't know that that's the only place. But
you can throw them under the bus. We really don't like them. I know
places in New Hampshire,
Massachusetts area.
They're using brass threaded piping because copper won't hold up, things like that. So PEX in its various forms could be an absolute game changer in scenarios like that.
What about all the fittings and stuff that come with PEX?
The types of fittings, the types of PEX.
We don't have to get into the names of do we hate this one or that one, but just an overall sense, is plumbing moving in the right direction with these compression type fittings where, hey, you just get out your fancy tool, your MK1-EG3 and, you don't say, I watch your videos, man.
So there's a million different, there's not a million. There's a handful of different types. There's basically 3 types of PEX, regardless of brand. There's A, B, and C, and that's how it's made. It's not a classification other than the type of, the way that they extrude it, the way that they cross-link it, things like that. Cold expansion, the type where you're literally expanding the tubing to fit over the larger diameter fitting. You've got the type where you're pressing it together with a.
I mean, there's some. We just did one where it was a click-in system, and I was like,
push to connect.
The fact that works, like the engineering behind it is pretty stinking cool. But I'm not a plumber. I don't put this stuff in, and more importantly, I've never been called to fix a plumbing system.
Right.
So you get to see the beauty of having this conversation with you is you're the one who gets called if that fitting fails a year later or 2 years later.
And we've actually, Matt and I have made videos on this and I've shown a lot of it on my videos on social media and stuff. There are a couple of them that are not my favorite. Okay. The type that have those pinch clamps. I think they're a little more popular down by you in Missouri. Not to name any names.
Well, they moved away from taping the joints to now those pinch clamps.
Taping them.
Yeah.
The press, like with the stainless steel sleeve, that seems to be a very robust connection. The expansion is favored by a lot because on the plumbing contractor side, special tools most people aren't going to have to work with it, that kind of thing. So that is not lost in our community. We're still very much in line with trying to make things harder for people to work on than ourselves, that kind of thing. Is what it is. The push to connect stuff,
billable value.
Yeah, well, exactly. The push to connect stuff is gaining popularity. Maybe not in the contracting space. There's a lot of reasons why contractors might want to look at that. Reliability. I'm not sitting on the fence here, but I'm going to tell you, I don't see it fail. When I see it fail, I hate to say this because it sounds so much like the manufacturer, but it's usually installer error or application error.
Yeah, you don't get it pushed together correctly.
Or you shouldn't have been using it for, it wasn't necessarily made to be used on that kind of piping system. Because believe it or not, we're talking about hot water. We're talking about houses. We're talking, there's a lot more piping systems that these fittings go in. We can use them for air. In some cases, we can use them for different chemicals, processing, things like that. So like everything has its application and not all of it, not one fitting system works for all of them. Right.
Yep.
And then in any case, no matter what, they have to be installed right with the right tools, the right fittings, all that kind of stuff. I think the conversation should go here real quick. If I can tell you this, you guys are builder, or you're obviously an architect and involved in the building process, but as a builder, you should know this. And I've talked about this in many videos. I think it's important. You should know about warranty and what the warranty on a piping system truly means in that. You talked about some of these companies are warranting their PEX for 100 years or 50 years. I think usually it's like 25, 50 years, something like that for the major ones. There's a lot of caveats that go along with like conditions that you have to meet in order to make those warranties.
Yeah, it's like a roofing warranty.
Yeah.
Right. Yeah, you can install these asphalt shingles, but it has to be this nail at this spacing with this edge distance and this temperature where the little tabs melt, and it's you're never going to meet it.
Right. It's no different for plumbing system either. So there's a obviously instructions on how they want you to install their piping. That includes things like what types of supports to use, how the intervals at which those supports are installed, what you can have in contact with your pipe. Start thinking about spray foam. Okay. Spray foam, not, we're not going to get into insulation, but that can actually be good or bad for a plumbing system, depending on the chemicals it's made up, the type of PEX you have. There's all kinds of information on that plays into the warranty. But most of all is this, because this is where we see the biggest problem is those warranties might be 50 years, but it might be 50 years. It's only going to be 50 years if you've used their valves, their fittings. All of the tubing that comes from that manufacturer, all of it is a system, right? You're looking at system approach, and that's very important. Yeah. Also, you should think about this too for your clients, for your well-being as a contractor. You're on the hook for a certain amount of time. But what if your plumber installed type, XX brand tubing and YY brand fittings together? Yeah.
Immediately you avoided everything.
You might have, they might not fully void, but it may decrease the length of the timeline of that warranty, the coverages allowed, that kind of thing. But maybe they don't work together at all, or maybe they were never really meant to be. And maybe they're using the wrong tool for this type of fitting and things like that. There's literally engineering behind all of this. It says why it has to be done. And if you don't follow those rules, that's the kind of thing you should be looking at.
Right.
Honestly. Right. So if you're going to, and you should consider that with any type of piping system.
Well, you should be considering that with any of the systems that are going into your house. Yeah. And for the most part, I feel like our industry doesn't read instructions, doesn't follow instructions.
We didn't get to the what.
That's okay. We'll skip it.
We'll skip it.
We'll end with, we don't follow instructions. I once,
I have one last question.
Hold on. I once talked to one of the roofers and said, "Hey, you're nailing this too high." And they had just started, so they'd only done a couple bundles. And he said, "No, this is how you're supposed to do it. This is what the manufacturer said." And I said, "It's not what the instructions say." And he said, "Well, they don't send us instructions." And I said,
It's on every shingle
actually,
bundle.
every single bundle that's sitting on this roof right now has the instructions on it. And he was like, for real?
Yeah.
And I was like, this guy has been doing roofing for 25 years. And I've only seen the instructions on every single bundle of shingles I've ever touched. And he's never bothered to read them. And he was about to tell me how to do it. So, and I'm not disparaging him. That's the way the majority of our industry that I run into.
We don't ask for
operates.
directions.
They know.
We don't read directions.
Yeah. I'm guilty of it. We all are.
So you make a perfectly valid argument when it comes to like, we should be better informed. We should be reading. And the number of people that I hear, even the people that I interact with on a daily basis that say things like, oh, well, Jake, you know the code really well. I don't know the code very well. I've just read the thing that we were going to talk about today. Like,
I know it well enough for this
I spent
episode.
20 minutes and I talked and I read the thing that I knew that our meeting was going to be about today. And I informed myself with 20 minutes worth of reading. Like, it's not hard to find this information. I just take the time to look it up from time to time. So now, do you still have something?
I do have one question.
Go right ahead.
Use Velcro much in your work?
Velcro?
Yeah.
No. Where's this coming from?
Well, I don't like to use it. It's a total ripoff.
Eric didn't know that was coming.
Wow.
So
That was awesome.
there you have it.
We need a cricket.
Yeah, we do.
Cricket.
Eric, thank you today for joining us on the podcast.
Yeah, thank you.
I'm glad that we caught you in the build offices today and said, hey, come sit in the podcast with us. We'll have you back again soon.
I appreciate it. Can I bring up one thing before we go?
Okay.
How cool is it that your Schedule 40 pipe, your iron pipe is your mic stand? Like, I've been looking at this whole time thinking, I need one of those in my own.
We had a
studio.
different mic stand, and it was kind of in the way, and it felt awkward. And Thomas, our engineer, literally went back into the shop and caught Johnny, the steelwork guy for Risinger Build, and said, I need you to make this into a different mic stand today. And this is what he came up with, and it was fantastic. So if you're only listening to the podcast audio wise, go and check out the mic stand here.
There you go.
It's quite funny, and it seems to be working just fine. So
Plumber's mic.
I like
until next time, thanks for listening and have a good day.
Bye-bye.